Periodic table and periodicity. Periodic table, this shows the arrangement or grouping of elements in order of increasing atomic number. Periodic law states that the properties of elements are in periodic function of their atomic number. Periodicity, this is the regular reoccurrence of a similar phenomenon at various intervals. Properties of periodicity. Atomic radius. It is measured from the nucleus to the outermost electron shell. It increases as we move down the group due to increase in atomic number and the number of shells. It tends to decrease as we go from left to right in the period. Ionic radius. Ionic radius is a measure of the space occupied by an ion or any direction of an ionic solid. It increases down the group as we move across the period. The cationic radii decreases from sodium to aluminum, while anionic radii increases from phosphorus to chlorine. Ionization energy. It is the energy required to remove an electron from an atom in order to form an ion. The ionization energy increases across a period but decreases down a group. Electron affinity. The electron affinity is the change in energy when 1 mole of electron is added to 1 mole of gaseous atom to form a univalent element of negative ion. The electron affinity decreases across the period from left to right but increases down the group. Electronegativity. Electronegativity is the ability of atom in a molecule to attract electron to itself. It increases across the period and decreases down the group. Groups and period. The modern form of periodic table is divided into 8 columns known as groups and 7 horizontal rows known as periods. Groups. The vertical column of element or group are numbered from 0 to 7. Elements in the same group have the same number of electrons in the outermost shell of their atoms. That is, they have the same number of valency electrons. Beside the 8 main groups, there are transition groups of elements. This lies between group 2 and group 3 in the periodic table. Periods. The horizontal rows of the element or period are numbered from 1 to 7. Elements in the same period have the same number of electron shell. That is, elements of period 2 have 2 electron shell Km. Those of period 3 have 3, that is KLM. Among the elements in period 6 and 7 are the elements of lanthanide and actinide series respectively. They are known as the inner transition elements. First 20 elements of the periodic table. This list will help you to remember how to arrange the first 20 elements on the periodic table. And it goes like this. Hello Helen, listen baby before coming. Never offend Florine. Nancy. Nana. Maggie allows Silas pass so close after kissing Clara. So for the group 1, we have hydrogen at period 1, and at group 0 we have helium at period 2. At group 1 again, period 2, we have lithium. Group 2, period 2 we have beryllium. Group 3 period 2 we have boron. Group 4 period 2 we have carbon. Group 5 period 2 we have nitrogen. Group 6 period 2 we have oxygen. Group 7 period 2 we have fluorine. Group 8 of group 0 period 2 we have neon. Group 1 period 3 we have sodium. Group 2 period 3 we have magnesium. Group 3 period 3 we have aluminium. Group 4 period 3 we have silicon. Group 5 period 3 we have potassium. Group 4 group 6 period 3 we have sulfur. Group 7 period 3 we have chlorine. Group 0 period 3 we have argon. Group 1 we have group 1 period 4 we have potassium. Group 2 period 4 we have calcium. So group 1 are group 1s are alkali metals. Group 2 are alkali earth metal. Halogen are those from group 3 to those in at group 5 and group 7. They are the halogen elements. Group 7 are the halogens. Then the noble gases are the group 0. Then this 20 represent the atomic number. The Ca or calcium represent the symbol of the element. 288 represent the electronic configuration. The black represent the metals. The blue represent the metalloids, while the white represents the non-metals. Group 1. Sodium, potassium, each with one electron in their atmosphere, resemble one another very closely. Both are univalent, ionizing by the loss of one electron per atom. Both are powerful reducing agents and good conductors of electricity. They ionize readily to form positive ion by donating electrons and form electrovalent compound. They easily donate their atomos electrons, also makes the good reducing agents. The reducing property goes down the group. Sodium will donate one electron to become positively charged. Potassium will donate one electron to become positively charged. They react with cold water vigorously to liberate hydrogen gas and alkali, so they are also known as alkali metals. This reaction becomes increasingly vigorous on going down the group, example as the atomic number increase. The oxides of alkaline metal also dissolves in water to form very strong alkali. On heating, the triosonitrate 5 so decompose with difficulty to give oxygen and dinitrate 3 salts. The reaction goes like this: 2 atoms of potassium with 2 molecules of water to give potassium hydroxide and hydrogen. Sodium, 2